Today we will talk about how to configure communication connection between HMI and our PLC. You have two series PLC. One is FC5 series. Another one is FL6 and FL8 series. Because the configuration in FL6 and FL8 is same, so in this video, we just introduce the configuration about FC5 and FL8. First part, we will talk about how to make communication between FC5 PLC and our HMI. We can create a new project in FStudio Unified software. Then choose the corresponding hardware. My hardware is FC5M 40mm and the power type is DC. We can choose the Ethernet communication or serial port communication. This time we take the example for the serial communication, and the PLC is work as a master device. Baud rate YY5200, non-parity, and database is 8, stop bit is 1. Then the station ID is 1. Click on the message config, it will turn to the message mode. Then add the action to trigger this communication. You can use always on clockwise or other clock to trigger this communication, but always we choose none. And return to the communication information. There you need to select the action to select the function code for the different variables. So now we need to create new variables in global list. You can add and some int variables or word. Then turn into the communication information page. You can read input register, and the function code is 3x. Word type is word, so we can only choose the B. This variable BBBB to here. It is from 3x1 to 3x3. Or we can choose the len3 function code. And another is the read coil. We can associate these variables to the one from len-x or 0x1 to 0x3, and the write single register. This is int. Okay. This is int. Choose the int type. Okay. Then we need to check the PLC configuration, communication configuration is finished, but we need to add a program network in the main program. Otherwise, when I compile this project, will comes an error. Network is empty, pure main. So we needed to add this. Add a then download this file to download the project to PLC. The project is downloaded successfully. And then we continue to configure in the HMI software. We can choose the COM1 or COM2 because this configuration currently only supports the 485 wiring. So here we need to choose the this HMI is work as a slave device. We choose the Modbus server, and the communication type is 485, and the baud rate and data bit and stop bit. It's as follows. And we need to add the component to match with the PLC address. You can take a look at here. For address mapping, 0xn is equal to LBN subtract 1. So it means that 0x1 is LB0. So we can add some bit setting components. 0 LB0. LB0 to LB3 or LB2. Then add some numeric input. This is LW to LW LW2. Then we can download this project to HMI. Oh, I choose the wrong download method. I connected by the USB cable, so I need to choose the USB or Ethernet cable. Then we can use a BNC function. Oh. Set enable the VSM function for the HMI. scan this. We need to add a IP address same as the PLC network, HMI network. This is 0 segment. Then download. Try to scan again. Because just now I connected the Ethernet cable to a switch network, Ethernet switch, and this Ethernet switch is not connected to HMI, so I cannot find this network adapter. So now I connect the PC to the HMI directly. And choose a VNC. Now we can see there is no communication error info, and we can connect to the PLC at the same time and monitor to see the value. The communication works, and I can input the value. So you can see this communication works and can write value successfully. Also, we can set this value, then false, and I see it is on the. This is true. You can also write the value. You can choose the write single coil or write single register to write the value from PLC to the HMI. This register only do the read coil, and read register is only do the read action from HMI to PLC. And next one is if HMI is work as a slave device, as you can see. And this time we'll take example for the Modbus TCP server. We can enable the Modbus TCP and check the IP of the PLC. You can read PLC configuration. This PLC IP is 0 to 100. It is same address with HMI, so we need to change it in same network but a different address. Then synchronize to PLC. After synchronize the IP to the PLC, we need to restart. We need to restart the PLC to take the change effect. Then we can connect to the PLC again. Now we use the Ethernet switch to connect computer HMI and the PLC. Now we can connect by the Ethernet. Now you can look the PLC configuration is changed successfully. And then configure the HMI as a Ethernet client. Here we can disable this configuration. Then there is an easy way to map the PLC address to the Modbus address. You can firstly click on the slave network address, then config, import the global variables for address mapping. You can click on it. And this start address is 1025 because that there are some hardware input and output occupy some local register. So it is suggested to start the Modbus address from the 1025 and for the word register is ports from the 2561. Then turn to the Ethernet configure page. You can export this address configuration directly. We can export to the desktop. Then the configuration in the PLC side is finished, and turn to the HMI side. You can click on the Ethernet PLC and FLEXEM Modbus TCP tag. Here you can see we can import address tag, but firstly we need to import the HMI PLC IP, and the port number is fixed. We should not change and import address tag. You can directly select the JSON file format and click on this and add this new registers for device 1 and choose the address tag multi-copy. Or it cannot be multi-copy because it is not a maybe the tag name is not increased by a certain range. Device 1 and the address tag value. Value 1 and value 2. Then download this project to the HMI again. There is a communication timeout. Let me check. From can download this to the PLC. Because this project is downloaded to the PLC. Then now this communication works, and we can monitor these variables. Now we can control these registers. To input the value of this bit register or word register. Okay, that's all for the communication with HMI and FC5 PLC. Next part is to communicate HMI with the Codesys platform PLC, FL6 or FL8. So let's take FL8 communication for example. Here I created a FL8 project in advance. Then firstly we choose to communicate by 485 and the FL8 work as a master device. We can right-click on the device, then add device. Here is a Modbus 485 master 1 or 2. They are for different channels because on the FL8 hardware there are 2 channels 485 communication. So we can choose the channel 1 add device. And you can click on the 485 master 1 to add the slave device Modbus 485. Click on 485 to add the function code like read coils and read holding register and write coils, write registers. Then we can change the communication parameters. Double click on the Modbus 485 master. Here there is parameter options. This is communication parameters, baud rate parity, database stop bits. We can choose different change the parameters by select the value from the drop-down list. And now this is 19200 and non-parity. Then let's take a look at the real coils configuration. The function code is 01 and the offset is 0. It means that the start address is from 0x0 and the length is 1. So you can only read one coils for one time. We can adjust change the value to 20. And the length of this function code is 80. So you can set the value not up to 80. You can set 80. This is the maximum value you can set. Same as reading registers, the start address is 4x0 and the length is 40. We can set it as 20 as well to read 20 word registers at the same time. And write coils, avoid interruption and mixture. So we can change the start address to 20 because this length is from 0 to 20. So we can use 20 as a 0x20 as a start address for the read coil function. And the length we can also set 20. Multiple register is from 20 and the length is 20. And this is the configuration on PLC side. Then we can we turn to the HMI side. We use COM1 for communication, and the HMI works as a slave device. The device type we choose the Modbus RTU server. The communication type is 485 2 wiring. Baud rate is and the parity bit is none. Okay. Then we can add the LW0 is correspondent to the 4x1. Yes, you can see here. LW0 is 4x1. This is 0, and we can multi-copy. Copy for 10. And the button LB0. LB0 is correspondent to the 0x1. This is for it. These components are correspondent to the read coil register and read coil and read registers function. The next is the write coil and write registers. Start address is 20. Then enable VNC function. Download the project to the PLC. We need to connect firstly. The PLC IP is 100. Okay, we can download. Run this. Oh, the current value is 100. And we can set the HMI IP in the same network because I use a Ethernet switch. Then download the project to HMI. Okay. We connect to the PLC again. Oh, I need to change my computer's IP. Two five five. That is. I didn't power on the Ethernet switch just now, so I can scan the FL8 right now and log in and use VNC. Use VNC. The IP is it's 200. Okay, so the first two line is for read function. I can write a value or read the registers. As you can see, I write the value successfully. And then I can write the bit registers. This value. As you can see, and I can also write the coils or registers from the PLC. Write registers. As you can see, it is write successfully, and for the coils here, use the Control plus F7 to write the value directly here. So the communication for the 485 works successfully. And next is to FL8 work as a Modbus TCP slave. Now we can take a look at how to make it work. And we can, there is a address matching. There is a address matching table. In FL8, there local register called MW0. It is correspond MD0. It is correspondent with 4xy and 4xy, and there is some beta register for MX. It contains 16 bit registers from MX 0.0 to MX 1.7, and MD1 is 4x2. So we can add some registers and write down the address. For example, write register is MW1, and this one is MW2. Coil is MX 4.0 and MX 5.1. As you can see here, MW1 is 4x2 and MW2 is 4x3. MX and MX 4.0 is also included in the MX3 4x3. So maybe there is a data data mixture, so we can change another address is from MX 6.0 and MX 7.1 6.0 and 7.1. Then from this project we can add a Ethernet PLC because the FL8 is work as a TCP slave. So this time it is work as so HMI is work as an TCP master. We can choose Modbus compatible address driver and Modbus TCP. The PLC IP is 2100. Click OK. Then add the two registers is LW 4x1 because this is MW1 and MW2. MW1 is 4x2 and MW2 is 4x3. Add the two bit component. One is 4x40 4x40. And this one is 4x4 8. This is 8. 9. It's 9. Okay, then we can download the HMI program and project and the PLC project. Okay. Because this is the wrong IP. The correct IP should be 2.200. Download. And also because the HMI is not restarting, so this will be red icon. We didn't use this variables in the program, so we can read. This. Read coil. Read coil. Right coil. Okay. When we write value, you can read the write of registers. Mm-hmm. 45, and the read registers. And the coil. So this is how to communicate Codesys PLC and HMI by Modbus TCP, and the Codesys PLC works as TCP slave. There is another much easier way to communicate Codesys PLC with Ethernet HMI. For example, that is called tag communication. Here you can add symbol configuration. Then here there is a GVL list. If you want to, you can tick on the options which one you want to export the text. Here I just want to import the text of GVL. We can build in advance. Then to this option to build again. Then you will find 486 this project and FL8 communication. You will find there is a 485 master device application device file. Then you can import. You can add another. We can delete change PLC. We can delete this option and create codices v3 TCP. Here is an import variable tag option. There is an promise that for 43 series, it only supports 1,000 variable tags. For which models support tag communication and how many tags is supported, we already introduced in the first video about the product introduction. And then I can find this device file, device description file. Import. It will show imported successfully. You can view it. The IP is 200 to 100. You can find this text in variable tag library here, and then you can use. You can click on the device and choose the correct. Selected select the variables you want to display. This is 16-bit signed, and here choose another one. Also the write register. This is write register, read register, and read coil, write coil. Read coil and read coil 1. And write coil 1. Then we can download the project to HMI again. Log into the PLC. And VNC function. Because Okay. Then take a look at this. As you can see, we can also raise the value of the write register and read register. We can change to 65 and 23. So if you choose if you want to communicate PLC and HMI by Ethernet cable, it is recommended to use tech communication. It is much easier to for configuration, and the address mapping is more convenient because you just to choose the variable tag node to match the variable address one by one. So that's all for the communication parts. Thanks for your watching.